So actually, I will try to go through this talk quickly so that we can have Q&A. That probably is the most interesting part. Because maybe all of you are already aware of what is this. Like the goal of this talk is to give you the state of affairs, what is our current stack, and where are we moving in the next few months. This is how it looks right now. So if you've been testing IPC, you've probably deployed our Lotus plus Trantor peer implementation, and you have been using the IPC agent to interact with the network and so on. And we know that the UX has been rough, and there are a lot of we found a lot of bugs, we found a lot of inconsistencies, the network was going down, and one of the reasons is because like Lotus is prepared for a longest chain protocol, but when we squeezed in BFT instant finality protocol like Trantor, things started to break in unexpected ways. This is what we are using right now. Probably you knew about SpaceNet. So SpaceNet was the first testnet that we had for IPC with all of this stack. And in SpaceNet, the goal of SpaceNet was to be a rootnet, a fast rootnet that you could use to deploy your own subnets so that you didn't face all of the horrible finality in mainnet and all of this like UX experience. Once you have 30-second block times and like the long finality, then we have a mainnet. We've recently deprecated SpaceNet, so SpaceNet is no longer a thing because once we moved into the Solidity contracts, so after the release of the FVM, we were using for IPC, for all the logic of IPC, we were using native Rust contracts built into the peer implementation, and we shifted to and rewrote all of the logic into Solidity contracts. The reason for this is, of course, compatibility with the EVM. We run over the FEVM, and we could run on mainnet and calibration. The reason why we removed SpaceNet and deprecated SpaceNet is because it was no longer needed. Like you could deploy over calibration, so there was no need for an additional testnet. However, it came with its own drawbacks, which is that 30-second block times and the long finality that we are all suffering. So we hopefully will soon have a new SpaceNet, or we're rebranding it like Mycelium, which is a layer 2. So we will have calibration. We will have a layer 2 network, general purpose layer 2 network that you can deploy your subnets from so that you have the same user experience that you had with SpaceNet, with these low block times and instant finality, so that testing and the UX is better. But nonetheless, we still want to interact with mainnet, which means that if you want a subnet that anchors directly to mainnet, you will still have to, at least for now, suffer that UX penalty that block times and finality offers us. So the kind of things that you can do right now with IPC is you can deploy your own Mir Trantor subnet based on Lotus. So you can run your own blockchain with these consensus and deploy smart contracts, FEVM smart contracts. You can even deploy your own custom built-in actors in Lotus, because one of the things, I mean, we did a lot of work on trying to have our native actors deployed in new subnets so that we could run IPC, which means that all of that work have helped us understand how to do this process and like pipeline this process and streamline it so that others can configure their own built-in actors in WASM, even with the FVM not supporting user-defined actors. So it's kind of we're cheating because what we're doing is like you can deploy your subnet with a custom bundle and then have new actors deployed. The problem is that, there's the question of upgrades, like how do you let your users deploy these actors? But this is the current state of affairs. And the last thing that you can do, so you can deploy smart contracts, have your own blockchain, and also have some basic cross-net transactions, which means that you will be able to move Filecoin up and down your subnets and send certain kind of transactions, like trigger the call to other smart contracts from your subnet to some other subnet that it's in the hierarchy. So this is the current state of affairs. But and here I have like an example of like how to deploy the UX of deploying a subnet right now, which means deploying an IPC agent, so a daemon, a process that is the IPC agent that orchestrates the communication with the different subnets in the hierarchy. You need to deploy the subnet smart contract, that is the one that will have all of your policy and the governance rules for your subnet, and then you can deploy the subnet and start interacting with the subnet. So you see that going from 0 to subnet is actually a great number of processes and a kind of a like involved process. But we think that that is not good enough. Like the feedback that we are getting from the builders and like all of you that have been trying IPC is that it is kind of rough. So it's there, but it's kind of rough. So we saw a lot of, as I mentioned, we saw a lot of problems with the integration of Mir, Trantor, and Lotus. Not because Mir is bad or Lotus is bad. It's just because Lotus was is use case specific, so it was built just for Filecoin. And when we were trying to generalize it, we thought it was going to be easier. It's not. So yeah. Then the fact that we were using Lotus and we wanted to be consistent with mainnet and so on made us offload as much as possible of the logic of the orchestration and so on to this new IPC agent daemon. But that was harming the UX. So we were like, okay, we're using Lotus, we want to be in mainnet, but we are killing a lot of our UX. So we needed UX improvements like configurability in Lotus. The fact that it's Filecoin specific and that we couldn't abstract a lot of these things made really difficult to make a peer implementation that was configurable. So, and we had a lot of technical, because of all of these, we had a lot of technical and design debt. So at that point, we said we need to do something. Like we're in a point where we're not getting good feedback from builders. We want to have this system operating reliably and sustainably. So that's why, with the help of Akos and Marco, at some point we did the call of like, okay, actually we started, when we were doing this, we were predicting this may happen. So we started a backup line of work where we explored the use of a new peer implementation that was based on a battle-tested consensus or SMR system, like a Comet BFT, which is the Tendermint core, like what was called Tendermint core. And for, I think it was from the beginning of the year, beginning of the year or even earlier. December. So in December, Akos started this exploration of like using Comet BFT as the core consensus module and have a full Rust stack that is just an application on top of Tendermint with FVM, IPLD, all of the actors and all the IPC specific logic to become the core peer implementation for subnets. So in that way, we controlled all of we had like this light or light-ish peer implementation based on a battle-tested framework that we could use to run subnets. And this had a lot of interesting consequences. So Tendermint can be used already. It cannot be used as an IPC subnet, but you can run it in isolation. So the integration is still in the works, but you can start making tests against it. It will be released in a few weeks, hopefully. And a lot of the good, like the nice consequences of using Tendermint, apart from the fact that it's a Rust stack that we're more comfortable with, we can control everything, we have more like levers that we can configure. We also managed to replace, because a lot of the logic, as I mentioned, a lot of the logic of IPC had to be offload to this IPC daemon to handle like all of the interactions and so on. And we managed to stream this IPC agent process into an IPC provider library because a lot of this offloaded logic could be introduced again into the peer implementation. So you just have to run your peer implementation. And if you want to interact with IPC, the same way that you use Ethers or some other library, we wanted to have the analogous for IPC, which is the IPC provider. Right now it's in Rust, it's a Rust library, but hopefully we will have other bindings and other implementations in the future. And the idea of all of this work, apart from to make the stack a bit more reliable and robust, was to try and fix a lot of the UX feedback that you all have given us of like all of the operation details and so on. So we're not yet there, but we're hoping that with this change, we'll be able to support a lot of the issues that have been raised. Another point I want to make, like Tendermint exposes the ETH RPC, so it's compatible with Hardhat, it's compatible with all of the ETH tooling. So we discussed about like also implementing the Lotus RPC, but there was no need at this point. No one asked for it. Everyone was asking for the ETH RPC. And actually, thank you for the Lilypad team because they helped us like flesh out the UX of that ETH RPC because we were missing and some bugs because we weren't using so advanced like event stuff, and they helped us debug that one, and we're comfortable that like we have the IPC provider to interact with IPC, but we also have the ETH RPC so that you can attack directly with ETH tooling your subnet node. And like where we're moving towards is to have this kind of hopefully UX in the future, which is just an IPC CLI that you say, we don't have the IPC agent anymore, we have the IPC provider and this CLI that wraps the functionality of the IPC provider. And eventually, we hope to be able to do IPC CLI subnet deploy. And that handles for you everything. And you can deploy your subnet. And we remove a lot of like the involved UX and involved interactions required from a developer right now to deploy a subnet. And yeah, and vendor-main subnets are close to be ready to be used as part of IPC, but they're ready already to interact with them. So if you want to start making progress into the integration with vendor-main, we have a bunch of scripts that Dennis has been working on to deploy a testnet locally for our rootnet in vendor-main so that you can start testing your contracts, the integration with your apps, and so on. And by the end of the month, probably, we will have like the first vendor-main subnets. So all the documentation to deploy vendor-main subnets from calibration. So the same experience you're used to with Lotus, hopefully, by the end of the week, the month, not the week, we'll be ready to test over calibration, and like we don't recommend it, but even mainnet. Okay, and now like I want to cover because like this talk is to tell you a bit of what is the current state of affairs, and hopefully to get a lot of feedback from you and answer questions that you may have, because our documentation is horrible. Like not only the UX, but the documentation, we could have done a better job. It's not clear, and there are several reasons why this is like this, but yeah, I'm hoping to cover as much as possible today, and like we'll be around the whole week, so please ask these questions. Something that I'm asked every time, like smart contracts in subnets, is this a thing? Like I can run my smart contract, of course. Like we run FVM, so whatever can be run in the FVM, it can be run in vendor-main. Like it's a blockchain powered by the FVM, so FEVM bundles with built-in system actors and so on. Everything is compatible. And as I mentioned, we expose the ETH RPC, so we implement the ETH RPC over vendor-main, which means that you can use ETH tooling. And if something doesn't work, please let us know, like Lilypad did, and we'll try to fix it. So how is a subnet deployed? I mentioned it before. So there are a few, this is covered in other talks. We're not gonna jump into the low-level details, but there's a subnet actor that determines the policy and like what are the rules of your subnet, and then you have the actual subnet infrastructure. So right now it's the IPC agent, the one that orchestrates all of these processes. In the future, the IPC provider, we want it to be able to help you deploy the subnet and deploy the subnet actor with the rules that you have. Right now we have a reference implementation of the subnet actor, but you could implement your own. Like, we have a bunch of levers there with a minimum number of validators, with a bunch of configurable parameters, but you could come up with your own and deploy your own. Like, this is, the idea is that you would be able to deploy whatever governance process you want over your subnet to be deployed in the contract, like in the subnet contract that handles this. This is another like $1 million question. When should I deploy over mainnet? When should I deploy over an existing general purpose L2? And when should I use our own subnet? The short answer is like, it depends on your use case, I don't know. But like these are a few pointers that you can consider when you're thinking about like, hey, mainnet, existing L2, or your own subnet. Mainnet we all know, has long finality at this point and high block times. We are hoping to solve this, but this is the current state of affairs. Which means that if you want to do DeFi, for instance, like don't go to mainnet because you're going to suffer a lot. Like a breach in mainnet, it could be a nightmare. Some people are doing it and they are heroes, but like it's hard because we're also facing for subnets that kind of problems. And then the other, like, and this is also something that is in our roadmap, but like it's not yet there, is native storage features. So if you need to interact with storage, like trigger a deal, I don't know, do retrievals, do something that is storage specific, I would highly, and that doesn't need to be high performant, I would highly recommend using mainnet because we don't have good support for cross-net storage features right now in subnets. But on the other hand, like if you want a shared security, high performance, small, like short block times with no custom features, Layer 2, something like Mycelium or some general purpose L2 shared by several use cases may be a good option because we're all sharing, like all of these use cases will have their own validators, hopefully, so they will all be contributing to the shared security of the Layer 2. And you don't need anything, like you need just high performance and fast finality, so you don't need anything weird that you should configure for your subnet. And finally, like what you want is to deploy your own subnet with custom features, your own built-in actors, like your own security model, your own governance, and so on. Maybe what you need is your own subnet. But again, this really depends on your specific use case. I can think of a few use cases that will fit each of these cases, but it really depends on what you want and what you need out of a subnet. Yeah, and back to another question, like can subnets interact with mainnet? So we have a bunch of crossnet primitives already implemented that allows you to not only interact with mainnet, but with any subnet that it's registered in the hierarchy. So you would be able to send funds up and down to trigger smart contracts in some other way. Here, it would be really helpful to understand what are the kind of crossnet interactions that you want to do, to figure out like what are the levers, the configurability, like what is a bit of the API that you need. Because right now we have a really slim API where it's just moving fonts and like send an arbitrary crossnet message and so on. And it would be really helpful to try and narrow this down so that we have a clear SDK, a clear API according to what the kind of crossnet interactions and like the crossnet requirements that subnet users and subnet developers need. And finally, how can I decide where to deploy a subnet? It really depends on your use case, but here are a few rules of thumb. Think about your crossnet interactions, the crossnet interactions that you need, because if, for instance, like you're in the bottom, like root T02 subnet, and you interact a lot with crossnet interactions with T01, T02, you're gonna pay a lot of message fees and a lot of like overhead of having to go up to the hierarchy and down. So if your use case, it's there's a bit of like engineering on how you structure or where you position in the subnet according to like what is the kind of interaction that you're expecting, what is the security anchor that you need, and so on. Because then there's the follow-up rule, which is that if you're moving a lot of if you're moving a lot of value in your use case, maybe you want to anchor to a high collateral parent so that validators there has skin in the game. So if I'm deploying my use case in a low collateral with just a small number of validators, if things go wrong, like I wouldn't move a 1 million Filecoin transaction there. So that's another thing to consider. Not only like your crossnet interactions, but also what is the security model of your parent, because your parent is your anchor of trust. So if I'm not trusting anyone, we can always go to the root. The problem with the root, we know what it is, like at this point, long finality and block times. And yeah, and also like something that maybe right now, I don't think we should worry about this, but in the future, once we have more than one consensus algorithm and once we have like geographical zones, we may want to have a parent that is close to us so that we optimize latency and other kind of like more physics related requirements. But this is something that at this point, I don't think we are considering the kind of use cases that we're discussing, but like it's something that it's in the roadmap also, because at one point we want to be able to have like subnets that operate in a small data center geographically and that just communicate every now and then with their parent and trigger side effects. And this is a bit like the rules of thumb. There's a lot of work to do in IPC, so if you want to contribute, you're more than welcome. It's a really cool project with a lot of stuff. But what to expect in the next few months, we want to figure out the upgrade story, because like we have several things that may need to be upgraded before we can deploy in production, which is first the IPC protocol in itself, which is a bunch of smart contracts that need to be upgradable. Subnets will need to upgrade. So if my parent upgrades IPC, my subnet needs to pick up that upgrade and upgrade its own IPC. And also, like we may want to upgrade the peer implementation. So if we have Fendermint with a specific consensus, we may want to upgrade the peer implementation in the future. Slashing is something that we don't have for validators right now. It is in the model, but like it's something that we're working on and will come soon. This is something for which I need all of your help. Like, please let us know the kind of crossnet interactions that you need for your use case. We need to know them so that we flesh out the API and the gas models and fees. Like, it would be great to know the kind of incentive models and like the gas fees that you're expecting from IPC so that we can have the levers there and like build the IPC incentive system to fit the needs of like a great gamut of use cases. And another thing that we need to like, because of course we right now, like you can deploy your Fenderman subnet, but there's a limit on what is the configurability of your peer implementation, and we need a lot of work on UX, DX, the knobs and the configuration parameters that we want to support, tooling, Rust libraries. So you see that there's a lot of work, and yeah, we're open for external contribution, and any feedback that you can give us, it would be really useful, because at this point we were building a technology that is really broad, and it would be really helpful to start narrowing it down to and like figuring out the APIs that everyone needs. And yeah, this would be amazing. So actually, I don't know if you've heard about this yellow runtime thing, but the idea is that, so Fenderman was this first idea of having a general runtime. The long-term vision is to have some kind of customizable blockchain so that you can configure everything, and it's easy to just deploy your actors and configure the blockchain to your specific needs. And the end goal, so I was saying that we are hoping to have like a CLI that it makes it really easy to deploy subnets and like interact with subnets. In the long-term future, what we want is to have like some kind of Terraform templates that would allow you to deploy whatever blockchain you need that is IPC enabled. So to have the same way that in Terraform you define like your template of the infrastructure that you want to deploy, what we're envisioning is to have the different modules, built-in actors, through CIDs, pull all of these processes, run, and like configure in a programmatic way the kind of peer implementation that you need, instead of like just giving you Lotus-based, Fenderman-based. So to have a way of have an actual configurable peer implementation for your subnets. And of course, like all of these blockchains eventually will be IPC enabled. We may be missing a lot of stuff, and it would be great to have a full visibility again of your use cases. That's why like George prepared this amazing track with builders talking instead of us giving the talks, because that way we understand what are your pain points, what are the kind of things that you need out of IPC or like the blockchain space in general. And yeah, I think I stressed this enough. Like, please, feedback, requests, questions, concerns. It is really useful. When we talk with people, like we realize all of the things that we're doing wrong. Thank you.
All right. Are there any questions? I will start distributing microphones.
You had a kind of a graph of various subnets, a hierarchical graph you had there of different subnets and that. Yeah. What would be the decision that would, you know, what factors would people need to consider as to whether or not they're anchoring into another subnet or anchoring in mainly to the root? I mean, why doesn't everybody anchor into the root, for example?
You could, but there's an issue there. Like imagine, so let's put the example of root T01. It has block time 1 second, and T0101 and T0102. If I want to do a cross-net interaction with between the children, I just pay the consensus overhead of my parent, which is 1 second block times. If I anchor in mainnet in its current state, I need to pay 30-second block times plus the finality.
Right, that makes sense. Okay, thank you.
But of course, like it's a trade-off between security and performance. So it really depends on your use case. If you rather have like the strong security of mainnet, even if I pay this price for the cross-net interaction, it's up to you.
Cool. Sorry, I didn't know if there was anyone else. Yeah, this came up at the end of our talk as one of the questions, and I wanted to kind of send it back to you in a sense. It was this question of support for moving ERC20 tokens around between, say, mainnet and a subnet, or between like a subnet and its child. I just wondered, I'm curious to understand what is involved with that, and kind of how you feel about that use case.
Yes. We need to sit down, together.
Okay.
Because that's we were discussing actually after your talk that this is something that it's gonna become useful for everyone. So we should figure out I don't know if it's clear by now, but like all of the native token that flows through the hierarchy, so all of the collateral, all of the cross-net interactions, all of these, the gas payments, all is in Filecoin, in Fil. At some point, we discussed doing, and this is feasible, which is doing a subnet where you choose your own token. So your native token is not Filecoin, and you do a peg, right? So you peg kind of like in the FX market, in the currency market. You peg according to your supply. So whenever someone releases, you do the dynamic peg, taking the collateral or the circulating supply that it's put in mainnet and the amount that it's in the subnet. The problem with that is that the moment that your token goes to mainnet, it is converted into the equivalent Filecoin. So it's not an actual ERC20 that goes up. The next thing is, and this was in the MVP, it's not a feature that we have right now in the production system, in this version, which was the atomic execution. So ideally, we should have, you should be able to have, and this is why I want to sit down with you, your ERC20 and the its counterpart kind of like in a bridge in mainnet so that you can move freely your token. So you would have like, instead of a single ERC20 contract, you would have one in each subnet you want to interact with. So that way you have so the same thing that you have with Filecoin, you would have it for your ERC20. So you would be able to release and fund through crossnet interaction. So those are the three flavors. And the one, I guess that the one that you're interested in is the third one. And that's why it would be great to sit down throughout these days.
Is that like cross-chain bridges where you'd be like, send it here, it holds it, and then it releases it upstream, actually, and that kind of model?
That's how it works for Filecoin right now. So IPC, the protocol under the hood, is doing that. It's burning some funds in your subnet to release it up and the other way around. And it has we have this firewall requirement to ensure, so the parent ensures that even if there's double spend, there's a limit of the amount. So you can only release at most the circulating supply, so there's a limit on the attack that you can do. But that's only for Filecoin and the native token. What we want to generalize that is for any kind of token. And that's why, like,
See, I'm just going to say the question earlier now makes a lot more sense. I think at the time I was like, well, of course it's going to work. It's a Solidity contract. And now I was like, oh, yes, of course we have to go between layers. So, sorry, I didn't quite understand your question earlier. Can I throw a very quick other question, a different one? And sorry if this is just me not understanding stuff, but I suppose this is the point, right? So, like, in your view, knowing what you know about Lilypad, right? So it's just like, what do you think we should do type question. Like, is the design of IPC such that we could spin up subnets for a deal and then kind of close the subnet once the deal is finished? And so the second part of that question then is like the kind of the Lilypad route, not the IPC route, would be like TO1 in your diagram. And then we would go, oh, look, there's a deal. And we want sort of fast interaction between the nodes who are creating the consensus group at that lower level. So is that kind of like what is supposed to happen here, or have I just got it completely wrong?
No, that's the dream. Actually, because we want to have like long-lasting layer 2s and also like these ephemeral layer 2s. The issue and why we're not focusing on those ones, and again, let's sit down and maybe we should prioritize this one, is because there's an overhead right now in the deployment of subnets. So our subnets, we're trying to make, with Lotus it was like, no way, you needed a full minute to bootstrap the network and so on, or even more. And with Fendermint, we may be able to reduce it, but in the end, like you need to bootstrap like a full-fledged consensus, a full-fledged blockchain, so it's not as ephemeral. I mean, even if it's ephemeral, like there's a like bootstrap time that maybe we cannot afford for that kind of use case. So something that we want to understand is what is the minimal. And that's why like this yellow runtime and all these discussions on like peer implementation, configurability comes into the table, because like we need to understand what is the lightest implement, because we want to go from optimism as a layer 2 to like ephemeral subnets where you just run a job, submit the result, and like forget about the state. And the problem is having a peer implementation that supports both, because for instance, like bootstrapping Fendermint or bootstrapping Lotus with the full-fledged consensus is slow. So how can, or what are the security trade-offs that we can pay so that we have something that supports both dimensions?
Yep, no, that makes sense. Thank you.
But yeah, that's the dream. So let's sit down.
Yeah, no, perfect.
All right. Any final questions since we're already over time? No? Oh, there's one.
I have a question regarding the roadmap. It's not clear to me when can I deploy smart contracts on IPC subnet that is connected to the Filecoin mainnet.
You can do it today, but I wouldn't do it. So by January, so Q1, we want to have an audited version, like mid-January, if nothing goes wrong. So we already hired the contract of the auditors, because like the thing is that the contracts right now, they're heavily developed and they haven't been audited. And we have to handle like stake, collateral, like actual money. So we don't want to risk it.
And is there any running subnet that is publicly available and is connected to the mainnet so that they can use it for development until it becomes production ready?
It is connected to calibration net. So we currently have a layer 2 connected to, maybe we could have one with mainnet with no. But right now there's one in there's one in calibration.
Okay.
Using Lotus, and hopefully in like end of October we will have one with Thunderman.
Thank you.
Yeah, I want to add something. So we plan to have, besides calibration net, we plan to have a L2 connected to mainnet. It will be a little bit after the public release that Alfonso was talking about in January. And he mentioned its code name is Mycelium. So the idea is we will be creating general purpose public L2 for Filecoin, where anyone who doesn't want to deal with deploying subnet and thinking how to secure own subnets, they can just like deploy smart contracts that executed in Filecoin ecosystem with access to mainnet, but it's in the same time, it's a fast, cheap, and secure. So to solve like general purpose computation problem for EVM developers.
Yeah, that's what we're looking for. So it will be Q1 next year.
Yeah, and it's this existing L2, so it would be the shared security model in this.
So you get the last question. Only one. Don't ask three.
So I imagine that in order to realize their potential, like at least some of the subnets will need to become like ecosystems or like more sophisticated networks, and for that they'll need to be integrated with like bridges, oracles, etc. Are you in touch with some of like with the ecosystem, getting input from them, or whether I don't know if that even if they already try that, right? What's their take?
So I don't know if Mikhail I can answer for myself. From my side, no, we are not interacting with the community. Like we have this, baked this by design bridge, let's say. In Subnet you have a way, but we don't have bridges to other networks. And this is something that we need to figure out, but I don't know if we're collecting requirements for and talking to the community already for that.
So we're thinking about some of the services. So we're working with one of our partners. It's part of the Glyph who want to create bridges. For example, one of the use cases is when you want to move funds from mainnet to subnet really fast. And now the finality time on a mainnet could be like 7 hours. So it could be, somebody could build a bridge that retain like small percentage of your amount and move it in a matter of seconds instead of waiting 7 hours. Just like it's like insurance against a late reorg in the mainnet. That's a simple solution that you use kind of financial technology to streamline some of the engineering challenges. But in addition, I think Arseny, you will be talking today about Protofire and Genesis Arc. Yeah. It's like a service for creating subnets really fast without deploying your own hardware and going through the motions of configuring every single bit of the subnet and thinking about security. So like we thinking about some of the services, but if you have a particular requirement or you want oracles, you want something else, let us know. We will be happy to collaborate.
All right, fantastic. So you still want to say something? Go ahead. Yes.
Yeah. You were also mentioning about the Terraform scripts and all that. I will be also covering that, like the solution that we want to build, like ideally would consist of like 2 separate sections. The one is going to be like more of DevOps friendly, that is going to be more of like Terraform scripts and all that, that's going to be configurable, tunable as like, and the other is going to be more of like on the like as user friendly as possible, and we are going to be like balancing there. So yeah.
Thank you.
All right, fantastic. Thank you, Alfonso.